This is a lesson about composite functions. Now, a composite function is the outcome of applying one function followed by another. So, for example, if f is the function x squared, so f of x takes a number and squares it, and g of x is the function 3x plus 2, so it takes a number x, multiplies it by 3, and then adds 2, then fg of x means to take the x, apply the function g to it, and then apply the function f to the result. So take the x, then apply the g to it, and then apply the f to the result. So it's actually reading from the inwards out rather than reading from left to right. Take f, apply g, apply f to that. So we can do this in a flowchart. Take the x, going to apply the function g to it first. So we're going to multiply it by 3 to get 3x, and then add 2 to get 3x plus 2. So that's applying the function g to it. Now, to apply the function f to the result means we're going to square what we've got. So function f says square it, and if you take what you had before, 3x plus 2, and you square it, you get 3x plus 2 squared. So fg of x is 3x plus 2 all squared. That's the result of taking the x, applying the function g to it first, and then applying the function f to the result. So I'm just going to move that up to the top so that I've got room to say that we can also do this algebraically. So fg of x means to take the x, do the function g to it, and then do the function f to the result. So it means to take the x and then work out 3x plus 2 and then do the function f to the result of that. So remembering that function f means to square something, then it means to take the 3x plus 2 and square it. fg of x equals 3x plus 2 squared. Now it's important to note that we do not read this from left to right, but we read it from the inside outwards. So take the x, apply g first, and then apply f to the result from the inside outwards and not from the left to the right. Now, gf of x would not mean the same as fg of x. They're not reversible. So it's not like a commutative operation. Gf of x would mean to take the x, apply the function f to it first, and then apply the function g to the result of that. So in a flowchart, take the x, we're going to apply the function f, which means to square it, and then we get x squared. And then we're going to apply the function g to the result, which means to first multiply that by 3. So take that x squared and multiply it by 3 to get 3x squared. And then add 2 to that to get 3x plus 2 squared. So that's different from what we got for fg of x. So I'm just going to move that to the top so that I can say that we can also do this algebraically. So gf of x means to take the x, do the function f to it, and then do the g to the result of that. So it means to take the x and square it in this case, because function f says square it, and then do g to the result of that. So apply the function g to x squared. So remembering that function g says to multiply something by 3 and add 2, we're going to take the x squared, multiply it by 3 and add 2. So we're sticking x squared into the function g rather than sticking x into it. And that leaves us with 3x squared plus 2. So gf of x is 3x squared plus 2, as we saw from the flowchart.